In text normalization, we undergo several steps to normalize the text to a lower level. Before we begin, we need to understand that in this section, we will be working on a collection of a written text and the oral text that is, we'll be working on a text from multiple documents, and the term used for the whole textual data from all the documents altogether is known as corpus. So in this section, we try to understand the text normalization steps. In text normalization, there are 6 steps. First one is the sentence segmentation. Second, tokenization. Third, removing stop words, special characters, and numbers. Fourth one, converting text into a common case. Fifth one, stemming. Sixth one, lemmatization. Before we begin, let us convert the abbreviations, shortcuts, slangs into a standard form. We call it as a canonical form. Like we usually write in our chat messages and use in our language orally, those must be converted into a standard format that is called the canonical form. Oh, on my way, you are welcome, between, do I know you, hope this helps, late, shut up, end of message, homework, leave a message, please, sorry, wrong window. All these must be converted into a canonical form. First step is the sentence segmentation. So in this one, the whole corpus is divided into sentences. So a paragraph will be given to you. You have to divide the paragraph into sentences. We know a sentence starts with a capital letter and ends with a full stop. The same way, you have to divide the paragraph into different types of sentences. The second step is the tokenization. In this one, divide the sentence into the tokens. What is a token then? A token may be a word, special character, or a number. Let us go back to the previous example and take the second sentence and divide that particular sentence into a token. Identify each and every word, special character, and number and keep them in a box so that it will be easy for you to count how many tokens are there in a particular sentence. The third step is the removing stop words, special characters, or numbers. In this step, the tokens which are not necessary are removed from the tokens list. Stop words are the words which occur very frequently in the corpus but do not add any value to it. Humans use grammar to make the sentences meaningful for the other persons to understand. But grammatical words do not add any essence to the information which is to be transmitted through the statement. Hence, they come under stop words. Some examples are given here as a, and, are, as, for, it, is, into, in, if, on, or, such, the, they, to. These words occur the most in any given corpus but talk very little or nothing about the context or the meaning of it. Hence, to make it easier for the computer to focus on meaningful terms, these words are removed. Along with these words, a lot of times our corpus might have special characters and numbers. Now, it depends on the type of corpus that we are working on, whether we should keep them in it or not. For example, if you are working on a document containing email IDs, then you might not want to remove the special characters and numbers, whereas in some other textual data, if these characters do not make sense, then you can remove them along with the stop words. The fourth step is the converting the text into the common case. The whole text must be converted into the preferably lower case. This ensures that the case sensitivity of the machine does not consider same words as different just because of different cases. Here in this example, there are almost 6 forms of hello would be converted to lower case and hence would be treated as the same word by the machine. The fifth step is a stemming. In this one, The remaining words are reduced to their root words. In other words, stemming is the process in which the affixes of the words are removed and the words are converted to their base form. Healed is a word. The affix of this word is ed, and the stem, after stemming we are going to get the word that is heal. Like that, healing. The stem word is heal. Healer, affix is er, and we got heal as a stem word. Studies, the affix is es, and we got the stem word as a study. Studying, affix is ing, and we got the stem word as a study. Note that the stemming words which are we get after removing the affixes might not be meaningful. Hence, in this example, as you can see, healed, healing, and healer all were reduced to heal, but studies was reduced to studi after the affix removal, which is not a meaningful word. Stemming does not take into account if the stemmed word is meaningful or not. It just removes the affixes, hence it is faster. The last sixth step is the lemmatization. Stemming and lemmatization both are alternative processes to each other, as the role of both the processes is same, that is removal of affixes. But the differences between both of them is that in lemmatization the word we get after affix removal is called, also known as lemma, is a meaningful one. Lemmatization makes sure that the lemma is a word with a meaning, and hence it takes a longer time to execute than a stemming. After, you can see here, the healed is, after removing the affixes we got a lemma called heal, and healing also heal, healer also heal, whereas studies and studying also we got a meaningful word, that is study, as a lemma. Let us understand the difference between the stemming and the lemmatization. Here, the caring word after lemmatization we got as a care, as a lemma, and whereas caring after stemming we got as a car, as a stemma. With this, we have normalized our text to tokens, which are the simplest form of words present in the corpus. Now it is time to convert the tokens into numbers. For this, we'll use bag of words in the next session.